due the following Friday. So there's 2 assignments due next week. One on Monday, one on Friday. Monday's assignment should be relatively short. Friday's assignment, less so. So I am going to spend most of today trying to prep you for Friday's assignment. But before that, I have a few bits and bobs that I need to cover from Chapter 3 that I didn't have a chance to get to yet because I took too many days off in the middle of last month. So we have aggregate functions in SQL, much as we do in most other languages. We have function calls for these things in Python, in C++, in Excel, and so this is just how the syntax for them in SQL. We can include these function calls in our SQL commands, and they will generate extra field names, but they do come with some limitations on how you write that SQL command, because an aggregate function doesn't just grab one value out of the data set, it's grabbing all of the values returned by that select statement and smashing them into one. That's what aggregate means. It's a value built out of a whole bunch of other values. So generally, the parameter in the parentheses for these functions is going to be a column name, or a field name is what I wanted to say, but FLD just looked silly and unreadable, so I went with column here. And you can also use column names in the count function, but most of the time when you see people using the count function in an SQL query, they just use star, because they basically want to know the number of rows that is being returned by that SQL query. It doesn't really matter which column is being referred to, and so generally it's just quicker to type count star, whereas if you're summing something up, you're actually interested in summing up the numbers in a particular column. Out of these functions, sum and average only, of course, take numeric data, whereas the other functions work with text data or non-numeric data. But min max will return for text data the alphabetically largest or smallest string. So sum really implies I'm looking for a bunch of numbers to add together, and average really implies I'm going to add all these numbers together and then divide by the count, the number of numbers that I've added together. Any explanation required on these? You kind of already know what they should do. Now let me just show you how they work in context. In the context of an SQL query written to work with your university database schema. So you don't necessarily need to have it out, but that is the example that I'm going to go back to over and over in this class, just because that's what your book uses. So let's say that the intent is we want the computer or the database to tell us what the average salary of instructors in the computer science department is. And so let's assume that we work at a university that actually has more than one computer science professor. And we're not just going to grab, say, Francois' salary or Professor Wolf's salary or Justin's salary. We're going to grab all of their salaries, sum them together, divide by the number of professors whose salaries were summed together, and return that. That's what average means, right? I mean, if there is, average will work with one salary. It's just going to take the average of one salary, which will be that salary. But generally, when we're asking for average, we assume kind of assume that we're taking multiple values together and making one sort of representative value out of all of them. And so, what we might type in, what the SQL command that we might have our database execute for us might look like this. If I were to type this in Microsoft Access, it would create a new column and it would give it some random name like, I don't know, undefined 57 or something like that. I forget exactly what. But Generally, if we're writing a statement like this, I would use the as keyword to actually provide a meaningful name to the new column that gets generated. But in this case, we're going to grab all of the rows out of the instructor table where the value in the department name column is computer science. And we're going to take all of the salary values from all of the retrieved rows and average them. And the result of this query is just going to be a single row, a single value. And that value will be in a column named by the system. If we didn't use the as keyword, it will have some sort of generic name to it. It's basically creating a single column table in this case. And I don't know that this is necessarily always the way we use aggregate functions. Sometimes we grab other information from the database and add an aggregate function column or several in addition to the actual columns that come from that table or that collection of tables. So this is just a simple illustration of using one of those aggregate functions. Here's another intent. Find the total number of instructors who teach a course in the spring 2010 semester. This does not feel like something that would use the average aggregate function, but we had a list of 5 or 6 of them there. Probably total number, maybe count? Is that kind of what we're looking for? And so if we're grabbing out of the, I don't have a database schema in front of me here, but if I were grabbing values out of the, the teaches table? I think in the teaches table, I have an ID field, and that ID field is connected to instructor ID, the instructor table, the ID field in the instructor table. And so basically, out of that teaches table, I want to grab out all of the rows that occurred in spring 2010. Is there a semester field and a year field for that, Mr. Kapiski, in the teaches table?
Yeah.
Oh, perfect. So we just need to grab data out of one table. However, I guess if there were an instructor who was teaching 3 or 4 classes in the same semester, that instructor's ID would appear 3 times. 3 or 4 times. I probably don't want to count them 3 or 4 times. I probably just want a count of the unique names of professors who taught a course in the spring 2010 semester. Do we know any command for unique? Have I ever taught you that one? Distinct, yes, okay, good. I'm glad I mentioned it at some point. I didn't remember doing that at all, but yeah, this is probably going to be a select statement that has something to do with the distinct keyword being applied to the ID field in the teaches table. I don't need to connect to the instructors table for any reason because the IDs are there right there in the teaches table, and I'm not being required to print out, like specifics, like names of instructors or anything that I would have to go to the instructor table to find. I'm just trying to find the unique IDs of instructors, and this time it's not just from the computer science department. Any instructor who taught any class in the computer science, in the spring 2010 semester should be counted once. And I just want a count of all of the individual professors who taught at least one class in that semester. Do we have any idea how, from the previous example, do you have a guess as to how you would come up with a query that satisfies this intent? I mean, it's probably going to start with select, right? And we know what the from line is going to be. It's probably going to be something like select, and then there will be other stuff, probably count or something, but I'm going to stick with the stuff that's obvious that I know. From teaches, where, And I don't know for sure what the field names are, but I'm going to assume that SEM is spring, or SPR, even shorter, and year equals 2010. Okay, so I think that's all of the easy blanks filled in. What do I put on the select line? In the select clause. Total number of instructors. That's pretty much count. What am I counting? Oh, also, all of these aggregate functions have parentheses because they're functions. So what is the parameter of this function? That's going to be the field name, but if I just used star, again, it would count it would count the same ID multiple times if it appeared multiple times. I don't want that to happen. I just want distinct IDs to be counted. You know what? Does that make sense? That's not actually the way I'm used to using distinct or seeing distinct, but I believe that is how the book author told me this SQL query would work out. This makes sense? And you know what? Again, I would like to be in control of what this column is named, and so I would probably name it myself, instructor count or whatever, but I want that column name to be readable. I know that the generic column names that Microsoft Access picks out for me are just uniformly terrible. But okay. Let's see, what else do we have here? I don't know what I just did. Hit the wrong button. Well, once the projector turns back on, the next intent, I can see it on the student screens here. The next intent is actually a very common form of aggregate function that I see. Find the number of tuples in the course relation, and so tuple is row, of course, the relation is table. I want to know how many rows are in the course table. I mean, probably this number changes every semester, every year, as new professors get hired and add courses to different departments' curriculum. And so if we want to know all possible course entities that are teachable on this campus, we might want to run a query like this. Sam, what do you think? How would you write this guy? Well, it's probably going to start with select. Just about everything starts with select. Oh, I better not write on this screen. Select. And let me skip this. What should be on the, skip the rest of that select line. What should be on the from line, Sam?
It's on the course, so we just...
That's what the from line is for, the names of tables. I think the only table we need to worry about is the course table. We don't care if they're computer science courses or physics or whatever. I'm not going to need a where clause here. And of that list of prior aggregate functions, what do you suppose I want to use? Find the number of rows. Let me just back up and see what I had on that previous. Which one looks good to you?
Well, we're trying to find all the tuples, so I just count.
Yeah. What do you want to put inside those parentheses? Does it matter?
Well, we're trying to find tuples, so I don't know if the thing to find that data
Yeah.
in general.
Yeah, before we were counting IDs, and there, I mean, there were distinct IDs. It was worth putting something inside those parentheses. But here, I mean, we're just counting however many rows. We're not counting a particular column, and so star works just fine here. And so yeah, select count star from course. And generally, again, count or star means it is a wildcard character in SQL, as it is in just about every other computer application. Okay, the reason I wanted to talk about aggregate functions is because the use of aggregate functions allows us allows us the use of a new clause in our SQL query, which we haven't had the opportunity to use here before. Let me give you an example of that. It's called the group by clause. And so an intent that would force us into using the group by clause is something like this. Find the average salary of instructors in each department. So I don't want to just limit it to just computer science and electrical engineering or finance or history or music or whatever. I want a per department average of all of the instructors attached to that department. And so I believe I have a snapshot of the instructor table sorted by department name, so all of the people in the same department are clustered together here. And so I assume, since this particular campus pictured here only has one biology professor, the average for the biology professor salaries is going to be $72,000, but the average for the computer science department will be somewhere in the high 70s, maybe, low 80s. The electrical engineering average salary, $80,000. This one is going to be, finance is going to be $85,000. History, $61,000. Music, $40,000. And physics, probably low 90s, $91,000, something like that, 92 maybe. So what group by does, we only use group by in SQL queries that have aggregate functions in their select clause. Because what group by allows those aggregate functions to do is only aggregate over a particular field of interest. And the field that we want to group by is is the column name we're going to put on the group by line. So an example of this, I'm not going to make you come up with this one, but to find the average salary of instructors from the instructor table by department is going to look like this. And I don't just want one column in this result table like I was doing on the previous slide. I actually want to see the names of the departments that I'm getting the averages of here. So I'm saying print not only the department name, but also the average salary of only the salaries averaged for people within where the value of department name is the same. And so the limitation that group by, or the biggest limitation that aggregate functions come with is if they're used in a SQL query with a group by clause in it, which they generally are, then only the field names in the group by statement can be outside any of the aggregate functions in the select clause. And that kind of makes sense, because if we want to show all the department names, we don't want to be averaging department names. That doesn't even make sense. Average is a function that only deals with numbers anyway. But I mean, the department name in this select clause is the thing that the aggregate function is grouping by. So it makes sense that if all of the computer science salaries are being averaged, the department name will stay the same for all of those averaged rows that are being compressed into one value there. So it's legal to put department name there. But I can't really say select name, comma, department name, comma, average salary. Because which professor's name are we going to put for the average salary? We're not grouping by anybody's name, we're grouping by the department name. So it's obvious that department name will be computer science, but out of Katz, Srinivasan, and Brandt, there's no particular value that would make sense to also be in that select clause. Does that make sense to you guys? And I probably wouldn't want to group by instructor name anyway, because all of these instructor names are unique, and so that nothing would be averaged. If I did have two Nevilles teaching on campus, maybe in different departments, maybe in the same department, there would be an average Neville salary if I were grouping by instructor name. But otherwise, it doesn't really make sense to group by instructor name. Department name really makes a whole lot more sense. But only names on the group by clause can be outside of aggregate functions in the select clause. That's the main rule for SQL queries using aggregate functions. What would the result of this query be? Oh, I already predicted what the results would be, and so we know it's going to be a 2-column table, and the first column will be department names, the second column will be average salaries, named somehow by the system. The author just decided it would be named AVG_salary. Makes sense. Better than what Access would have come up with. And I think a lot of these make sense. An average of one value is that value. The average of 75, 65, and 92 is apparently 77.3. We pretty much figured that the average of these two values for the finance department would be 85,000, 61,000, and I can't math quickly enough to figure out what physics should be, but I'll believe 91,000. That makes sense? So what the group by clause allows us to do is provide context for the aggregate values that we're getting out of the aggregate function. Only certain rows will be aggregated in order to come up with those aggregate values. Any questions on that? Make sense? So the reason I wanted to teach you guys the group by clause is I want to start showing you SQL queries with group by clauses in them, and hopefully you'll understand what they mean when you see them pop up. So, what did we do in this class on Monday? We did some math fun, right? Some linear regression theory business. We figured out how to grab a bunch of x coordinates and y coordinates from a bunch of points on a graph and figure out if I were to pass a straight line through this cloud of points, then given these x and y values, that line would have a slope of m here that is built in a weird way out of a whole bunch of summation functions, and b, which is built out of m and a couple of average functions. In fact, I think I actually used average functions in the SQL query that I showed you last time. I used sums and counts without explanation and averages, and that's how I came up with my M's and B's last time. Okay. So, I don't remember, but I think for homework 4, no, homework 4 is what you're doing this Monday. Homework 3, in one of your recent homeworks, I had you upload a CSV file into an Access database, right? Into an Access table. You just use some sort of import function from one of the menus on the Access ribbon, and you import from a text file, and you say, fields are separated by commas and things like that. So, okay, I'm going to assume that if you have all of these airfares that you've been collecting up to this point in an Excel file, and maybe that Excel file's a tab sheet, that Excel sheet's name is fares 15, and maybe that's the only sheet that you have in your Excel file, and so you can save that file as a .csv file, which is essentially a text file of comma-separated values which can be represented as an Excel sheet. And I had you collect dates and times in two separate columns. And so in your Excel file, you probably have those values in two separate columns. And if you imported that CSV file into a table in Access, then you might think to yourself later, oh, this dude, he's going to want me to build a graph out of these airfares, and what he's going to want is combined dates and times on the x-axis, right? He's going to want not only the date, but also at noon or 6 p.m. or whenever this reading was, whenever this fare was collected, he's going to want a dot at the appropriate location over that X file. And dude didn't even ask me to have a combined date and time field, which I'm just referring to as CDT here. Have I told you about update? I don't believe I've told you about the update query. Again, the select query is 98% of all the queries that you're ever going to do, but every so occasionally, sometimes you're going to want to create a new field in your database and populate it with values that are combinations of values in other fields. That's what's going on here. And so the syntax for that is you use the update keyword, the name of the table that you're changing values in, and then set just says, this is an assignment statement. Make CD take on the value of this thing here. And you can even put a where clause on there, so you're only updating certain rows, the columns in certain rows with that expression. But here what I'm doing is I am basically updating all of the rows of a CDT column. I'm assuming that CDT column already exists. And I just want to demonstrate doing that in a database that happens to be named fares 15. These are fares that were collected in 2015. I believe I've used this data set before to show you examples. Can I? Yes, I can make these values a little bit more. Oh, I was looking at the wrong thing. I don't think I can make these values bigger. Okay. Let's see, select and change font size. Oh, there we go. That should be a little bit more legible. Okay. So, I have this table. It's got a date field, it's got a time field, but it doesn't have the two values combined as one. And I know that eventually I'm going to have to make a graph where the x-axis is going to be date and time, and so I need a column that has a combined date and time value. I know that dates and times are both represented by floating point numbers, and so addition will actually combine them nicely without losing any data. And so all I need to do is copy paste this SQL command here into an SQL window in my database and get ready to run it. I'm actually not quite ready to run it. There's already some code in here. I'm just going to erase it, replace it with the code that I promised would work. I can't actually set the CDT field to anything at this point because there is no CDT field in this table. However, I do know how to go to the design view. I'll just select the design view from this drop down here, and that will give me the structure of the table. And I can just right-click in the margin and insert a row and call it CDT and make it also a date-time field. I don't know what date-time extended is. I'm going to pretend it doesn't matter. And now, when I view this table, they're going to want me to save this new structure. Oh, good grief. The CDT is all the way at the other end. I don't know why. What does the design tell me? Design tells me it's in front of DT. Okay, whatever. I guess I can live with that. And so now that I do have a CDT field to update for all of my rows, I'm going to update it by adding together the date value and the time value. Where is my bang? It's right there. Exclamation point. Run. Sure. Update those rows. Because if there were values in the CDT field, then I would just have overwritten them with this query. So that's why it asks me to confirm what I want to do there. And so now when I go back to the Ferris 15 table, I see that there are values in CDT that are too wide to fit within that size of column. But if I compare the values in the CDT field here to the corresponding values that were added together to create this, that is 8/27/2015 at 8:05 p.m., then this is 8/27/2015 from the date field and 8:05 p.m. from the time field. So I've successfully been able to add those two numeric values together such that they're still representing the same data, except now they're in one field rather than separated in two. Is that all right? So you can use the update command to, if you realize that you did not structure your database the way you wanted to at the very beginning, and you need to change the structure somehow and then create some new fields and populate them with values that you can derive from existing values. That's not the only use of update, but it's a very convenient one. It's worth knowing the update command for that reason alone. But I just wanted to make sure that when it comes time for you to make another fair graph, which I believe will be for the assignment due a week from Friday, and if you do have your values in a database at that point, you can also do this in Excel, of course. You know how to combine them in both applications. All right, the next bit of stair step of knowledge that I want to talk about. So we talked about aggregate functions. I want to talk about, I want to build a SQL query that uses an aggregate function, the average function. It seems like a useful one to me, and I am grabbing all the data out of Ferris 15 and averaging all the fares, but only those fares for a particular date value is what's going on here. And I mean, I am saying that it's not a very useful query, but maybe it's good to know what the average fare is on a particular date. Maybe the first few days before Thanksgiving vacation, everybody's airfares go up, and so maybe the average fare has some meaning on a date basis. The reason that I say it's not necessarily going to be useful all the time is if I'm looking at this table here where all of these rows were harvested on 8/27/2015, I mean, these are not even all of the same flights, right? And so if I were to take the average of these fares, I would be averaging the SY flights together with the DL flights, and there's multiple DL flights, and they're probably going to different destinations. I don't know that it necessarily makes sense to average together fares by date unless I am looking for some particular seasonal effect caused by some holiday, but otherwise I don't really see a good use for doing that, but it does work. I'll show you it works. It gives you a single fare value for every day, and if that's what you want, then that's what the query gives you. Let me just copy paste this here to minimize typing errors. Back into my query. A standard query that we can understand. We've just learned group by. We know everything with the same date value is going to be averaged together, and that date value will be shown on the same row in front of that average fare. I haven't named my average fare column, so Access is going to come up with some name that I'll hate. Let me run that query. Yeah, I guess I can get a bunch of average values by date. I can see that overall, the airline industry, if I were to buy a ticket on 8/27/2015 in that first row, it would probably cost me, on average, $363.50. If I were to wait a day, the average cost goes down by $4 or so, $359. If I were to wait another day, it goes back up to $362.60. So I guess it's telling me some information, but from what I recall seeing in that table, and I guess by the end of September here, I can see that the prices are increasing. And of course, I mean, these fares were all, like you guys, we're targeting a particular departure date and a specific return date. And so it does make sense that as we get closer and closer to that departure date, the fares are rising. And so they were also tracking a departure date just a week or so before Thanksgiving, and maybe that was also having an effect, since a lot of people do tend to travel by plane just before Thanksgiving and just after. So anyway, okay, so that's something. But normally, I'm not going to care about what the entire airline industry is doing. I'm going to care about, well, if you guys, out of the 14 or 18 people who are taking this class this semester, I told you that you could choose whichever flights you wanted. I just told you it has to be between Minneapolis and Dallas-Fort Worth or something. What are the chances that 2 or 3 of you are actually tracking the same departure flight? Probably pretty good. At least 2 people in this class are probably tracking the same flight, and so that means we're getting contributions from at least 2 different people for at least some of these flights taken at different times of the day, presumably, and so now we have something that we can average together, perhaps not only by date, but also by flight number. We don't only have to put one value on that group by line. We can average stuff together by date and flight number and see how this particular flight is changing on average by day as we go through history. And that's something that you might want to graph in graphs when we start graphing this airfares data again. And so the group by clause is really useful in taking a whole lot of similar information and aggregating it into a single data point that you can plot on a graph on a daily basis in this case. An average fare for a given flight. Or maybe the average fares for all of the flights that are being tracked in this class from Minneapolis to Dallas-Fort Worth. But that would be a mess of colored lines in that graph. Generally, what people do is they focus in on 2 or 3 flights of particular interest and then just group by those flights and see how those patterns evolve over time. So that's one example of fun with Excel. So I'm not even going to bother going into presentation mode here, since I'm going to want to copy paste from this slide. Let me try to make it bigger though. So I am claiming that this top SQL query here, select date, departure airline, departure flight number, average fare from fares 15, and I'm grouping by all of the stuff that's not in an aggregate query. I have to do that. That's the rule. Nothing that's not in an aggregate query cannot be on the group by clause, or else SQL or Access is going to yell at me, or whatever database I'm using is going to yell at me. But we know, can we predict what this is going to be? We don't have a where clause, so we're not just focusing on a particular flight that we care about. This is going to generate aggregates of all of the different flights that have been contributed to this table by all of the students who are collecting data in 2015, and each flight is only going to be represented once per day. And so every row is going to be for a particular date, a particular airline, a particular flight number, and for that airline, that Delta 3758 on that date, we're going to get the average fare collected by everybody who collected that flight's data for that day. And so if I were to copy paste that into my SQL query, just to make sure that I'm not lying to you, that I know what I'm talking about, that I understand this thing correctly. SQL view, paste, and run. So now I have multiple rows for a given date, but significantly, each row with the same date value is actually focused on a different flight. And it turns out of this data set, apparently I had limited my students to only collecting data on 4 flights, because that's all I see. I'm seeing Delta Flight 1084, Delta 4123, Delta 5718, and then SY 235, and then we move on to a new day. So I only have data for those 4 flights in this fares 15 table, apparently. And so if I care about what's going on for flight 1084, I can't see the next value for 1084. It's a bunch of hash marks. Now those values aren't necessarily right next to each other, but I can sort of pick those values out. On 827, Delta 1084 was $437 on average out of all the people who collected that fare information. On 828, it had dropped to 419. On 829, it had climbed back up to 433. And if you remember the pattern of the overall data for this table, that's following it, right? The first day was relatively high. The next day, the average price had dropped. And then the following day, it had climbed up again, almost to where it was on the first day. And it probably makes sense that this data follows that same sort of pattern, because most of these flights that are being tracked are actually Delta flights, and I assume that Delta fares are going to rise and fall more or less in concert. And so they're the greatest contributors to that average. Maybe SY isn't doing the same thing. Let me check. On day 1, it was 235. On day 2, it was 235. On day 3, it was 235. This is why I think SY is Spirit Airlines. This feels like one of those budget airlines.
Sun Country.
Sun Country. It does not change very much from day to day, although I assume if we're tracking it over an entire month or 3-month period, we will see more change than what we're seeing in 4 or 5 consecutive days here. So, I feel like my group by queries are slowly getting more and more specific, perhaps more and more useful, more and more descriptive, rather than just averaging everybody together into the same date value average. What is this bottom query going to do? Oh, this is another variation on SQL select commands that I haven't had time to tell you about, but which I believe you will find very useful. If this, let's see, is this kind of almost the same as this top query here? So I often test out a query until I'm getting the data the way I like it. And if this is the data that I care about, that I like, maybe I want to put all that data into its own table. One reason why I might want to do that, let me bring you back to the winds table that you were looking at for the last couple of assignments. We have Bemidji wind values in that table, right? But how many Bemidji wind values do we have? Like 200, 300, 400 rows worth? How many rows total are in that winds table? Like 20,000? And so, if eventually we need to think about joining that winds table to another table, and all we care about are Bemidji values. Maybe I don't want to join all 100,000 values of the winds table to some other table. Maybe I just want to join the 200 rows of Bemidji values to some other table if Bemidji wind is all I care about. And that would certainly make less work for the database, and that it would be able to return results to me in a quicker fashion than if it had to match every row with a super large database, most of which we don't care about. A super large table of data. And so this is frequently something that I use. It's just appending to the end of the select clause the keyword into and then a new table name that doesn't exist. And what that will do is it will execute this query, and then all of that data that's being returned will be returned into a new table with this name here. So I typically call this a select into query. It's sort of weird in that it inserts its keyword into the middle of a selection query that already works, but basically we're putting it at the end of the select clause here. And it's a way of creating a whole new table. In fact, what I'm going to suggest that you do for Friday's assignment is grab all of the Bemidji data out of the winds table, because you already know what the Bemidji WBAN ID is. And so all you have to say is select star from winds where WBAN is equal to, what is it, 17,958 or something? Select star into Bemidji data from winds where WBAN is whatever it is. And then you have all of your Bemidji data in one table. And if you want to, for some reason, compare all of your Bemidji data with all of Park Rapids data, or all of your hometown data, or all of Black Duck's data, then you can do the same thing, extract those subsets of data into their own tables, and then when you're joining data from tables together, you're doing it with relatively small tables rather than some great big huge table that has data from Canadian provinces and islands out in the Pacific and stuff like that are never going to matter to you who care about wind speeds in the upper Midwest. Now, Canadian data might have some relevance to you, but maybe not Phoenix, Arizona data. So anyway, select into is a very nice version of the select query to know about if you want to spend less time waiting for your computer to chug through all of the data that's joining together and giving you a result that actually matters to you. All right? I still didn't get to the very most fun part, but you know what? If I were to try to keep you for a few extra minutes here in class, and it would actually be 15 minutes over class, I bet nobody would be left here at the end of those 15 minutes. So I'm going to stop right here, and I'm going to continue from this point on Friday. So don't miss Friday's class. It's going to be fun, Mr. Kopitsky. SQL join queries.